Okay, we're being asked to find a linear function that goes through these 3 points. Just a reminder that we have 2 different ways to do it at this point. We will have more as the semester progresses. We have the ways that actually use the slopes, but in order to do that, I need 2 of these points, for example, would have to have the same x-coordinate, which they don't. 2 of these points would have to have the same y-coordinate, which they don't. And so we're forced to just sort of use regular linear algebra, which is not a bad thing. That's one of the many reasons we'll have taken this class. So what we want to be able to do, right, is write down that z equals, and what we need is m and n and b. And I just want to start plugging in stuff. I know that when x is 1 and y is 2, z is 3. So we get an equation. I write down 3 is equal to 1m. That's 1m plus 2n plus b. Just a reminder that that's one linear equation in 3 variables, but I have 2 more points. When I put in 4 in for x, 5 in for y, and 6 in for z, is also supposed to work. So I'm going to get 6 equals 4m plus 5n plus b, and that's another equation in 3 variables, and I have 1 more point, so I will put in 5 in for x, 7 in for y, and 10 in for z. So I get 10 is equal to 5m plus 7n plus b, and what we have here is a system of equations, a system of linear equations, 3 unknowns. I'm going to write down the augmented matrix for this. Writing the coefficient matrix first, I get 1, 2, 1 like this, and 4, 5, 1 like that, and 5, 7, 1 like that. Remember, that's called the coefficient matrix. The augmented matrix, we add the extra column. Remember, to augment something just means to make it bigger, and that's all we did. It's not a big fancy word. And we want to put this in row reduced echelon form. I actually went to, I think, refcalculator.com, and I got the following. I got, I think, 1, 0, 0, negative 2, and 0, 1, 0, and 3, and 0, 0, 1, and negative 1. Remembering that minus 2 is m, 3 is n, and minus 1 is b. So our final answer that should work should be something like minus 2x plus 3y minus 1. And that actually does go through all 3 points. Ta-da!